Okay, so I've done the double distribution, 6 times 4, 6 times 7, 5 times 4, 5 times 7. I've done the FOIL first, 6 times 4, 6 times 7, 5 times 4, 5 times 7. Done the FOIL. I've done the box method, 6 times 4, 24, 6 times -7, 5 times 4, 5 times 7. And I'm going to do the same thing here. This, I multiplied these two. That gives me -35i squared, because I times I is I squared. This gives me a -42i. I multiplied those two together. Now I multiplied these two together. That gives me a +20i. And then that gives me a that's a +20i, and that's a +24. And then I combine all my like terms. So this one is going to be a -22i. I think I did that right. 42 take away 20, and then -35i squared. So same thing here. These two go together. So we get 24 -22i -35i squared. We got the same thing on all of these. So 24 -22i -35i squared. It is not simplified. These are not simplified because of this fact right here, because I squared is equal to -1. I'm going to go back now and show you how to simplify this. But all of these did simplify down to 24 -22i -35i squared. So what's going to happen now is every one of these I squareds is going to turn into a -1. So you have a -35 now times a -1. So you have 24 -22i. A -35 times a -1 becomes a +35. And the I squared is gone because we replaced the I squared with the -1. It is an equivalent value. So now these two numbers right here are like terms, and they can be put together. So what is that? 59 -22i. So the final answer to this one right here is 59 -22i. There's the real part, there's the imaginary part. Same thing, that happens all of them. This becomes -35 times a -1. Negative times a negative becomes a +35. Put that +35 together with this one, and you have 59 -22i. Okay, so that's where we get that. So it's 59 -22i, because the I squared became negative. So 59 -22i. All right, I am not going to work all four of these methods with all of these. So I don't know. How about, I think I would prefer to stack them. So I'm going to stack them. I think the stack works out pretty good. So I'm going to try to erase all this without taking up too much of your time. Okay, delete that. I'm going to delete this. And use the eraser here. So I'll leave the double distribution up there, but now for the rest of these, I'll stack 2 -3i and 3 -2i. That is a +6i squared. Don't know why my pen is so thick. And then that's a positive, and then that becomes -4i. That's a -9i, and then that's a +6. So 6 -13i plus 6 times negative 1. So that becomes 6 minus 13i minus 6. A positive 6 and a minus 6, we get 0 minus 13i. So the answer to this one is 0 minus 13i. Do you have to leave the 0? No, you could just put negative 13i. It's kind of understood. Okay. You can always rewind the video and watch me work that again. Let's see. That's the double distribution method still showing right there. I just did, what did I do on that one? The stacking method. So I'm going to do FOIL here. First, outer, inner, last. Okay, now I'm going to simplify. 25 plus 10i minus 1. This I squared becomes a minus 1, so that ends up being 24 plus 10i. Okay. All right, so that's how you multiply. You have to remember I squared. And just because your Springboard book talks about it, there are only 4 values of I right here. What page am I on? Page 128. Every power of I can reduce down, and these should all be I's. I don't know why that is not, it looks like a capital letter I, just misprint. These, all values of I can reduce down to either I, negative 1, negative I, or 1. All of these are just, can be simplified down to, basically you just divide it by 4. So 5 divided by 4, you have the remainder of 1. So I with an exponent of 1. 6 divided by 4, 4 we're going to 6, I don't care how many times, but you have a remainder of 2. So this reduces down to I squared. 7 divided by 4, I really don't care about how many times it goes into it, I care about the remainder. So it goes into it 1 time with a remainder of 3, so I cubed is negative 1. I don't think you have to work any of those problems, but I do want you to know that there are only, you should never see really any power of I bigger than an I, because it'll always reduce. I to the first power is I to the second power is negative 1, I to the third power is negative I to the fourth power is 1, and then any other power beyond that will divide down into one of those. So you should never have I raised to any other power. If you've got it raised to any other power, it's not considered simplified. Okay, so the next thing we got to do is we have to learn how to divide, but before we learn how to divide, I got to give you a vocabulary word, and the vocabulary word is a complex conjugate. So the complex part, we know what that means. That means we're dealing with A plus BI. And the conjugate, there are other places where conjugates happen. So we have conjugates that happen in binomials. If you have x plus 5, the conjugate of that is x minus 5. It's just the same exact terminology. We just have a plus sign and a minus sign. Where do you see this? In the difference of 2 squares. So when you have x squared minus 25 right there, the factors of that, those are conjugates of each other. So they have the same A term, they have the same B term, the B term just has opposite signs. So writing the conjugate, here's the thing, here's the binomial or the complex number. They want us to write its conjugate. Okay, so the conjugate of that one is 9 plus 2i. And then they want us to multiply them. Well, we know what happens when you multiply conjugates. You multiply, you do FOIL or double distribution or the box method or whatever. Those middle two terms are going to add to 0. You get 2 times 2, that's 4. I'm going to do FOIL. There's the first. There's the outer. You get positive 18i right there. And right here, you're going to get negative 18i. And yes, it's going to happen that way every time. You're going to get a positive number on the inside. You're going to get a negative number on the inside. Those are going to add to 0. And then this is negative 81i squared. Okay, now when this simplifies, these add to 0 because they're additive inverses of each other. I squared becomes negative 1. Negative 1 times negative 81 becomes positive 81. And then those two numbers are just numbers that you can add together, so that ends up equaling 85. So what just happened? We took a complex number, multiplied it by its conjugate, and it became just a real number with 0 imaginary parts. Okay, I don't really want to put the 0i because the whole idea here is that I start off with a complex number, I multiply by its conjugate, and I just have a plain old ordinary integer. What about this one? Be careful with this one. The conjugate of this one is negative 5. I don't change both signs. See, this 2 is positive, that 2 is positive. That first sign stays whatever it is. So if this is negative 5, this is negative 5. But the second sign changes. If this one's positive, this one's negative. 5 times 5 is positive 25. You can do the insides. I leave them. I just stop doing them. Positive 5 times negative 5 is positive 10i. This is going to be negative 10i, so I just skip them. And then I just do the first term times the last term. Those two are going to add to 0 every time. Positive 2 times negative 2 is negative 4i squared. That simplifies down to 25. This is minus 4 times minus 1, so that'd be 25 plus 4, so that simplifies down to 29. All right, so dividing is going to start right here with the conjugates. So I'm going to go ahead and stop this video, and the next video will start by dividing complex numbers, and the dividing of complex numbers, we begin with the conjugate.